Okay, continuing on, now we're going to create the standard equation of each circle from the information, and we're going to graph it. Make sure that when you're graphing it, you plot the center and at least 4 more points on its circumference. Okay, so this one's centered at the origin. It has a radius of 3. So normally this one's pretty easy. Let's start off with the graph here. So it's centered at the origin. So we have our origin right there, and then our radius is 3. So we just need to go 3 in every direction. And then connect your dots. So that looks lovely. Okay, there's our circle. There's our graph. Okay, the standard equation of a circle is right here. You're going to want to get this down if you don't remember it from geometry. This is the distance formula, just rewritten. So the distance formula, if you remember, was x minus, or x1 minus x2 quantity squared plus y1 minus y2 quantity squared, and that was equal to the distance. The only difference is that instead of x2 and y2, we use h and k, which are the center of our circle. And the distance represented in the distance formula is actually our radius squared. So it's just the distance formula. So if you can remember that, you already know the center, or excuse me, you already know the circle equation. All right, so plugging in what we know the origin was at 0, 0. That's going in for h and k. And they told me my radius was 3. So we're going to plug in h, k, and r to find our circle. So we have x minus h quantity squared plus y minus k, which was also 0, quantity squared equals our radius squared. And to clean this up a little bit, x minus 0 is just x, y minus 0 is just y, and 3 squared is 9. There is our equation in standard form. Okay, next problem. Okay, here's our second problem. They give me the center, which of course we now know is h and k. And the radius is the square root of 2. So if we were to come up with the equation first on this one, it's x minus h. So we have x minus 1 quantity squared plus y minus k, y minus a negative 3 quantity squared equals r squared, square root of 2 squared. And then just clean this up as much as we can. X minus 1 quantity squared plus y plus 3 quantity squared equals 2. There's the equation for our circle. And then to graph this one, the center is at 1, negative 3, so we start by graphing that. And then what I would recommend doing is just figuring out, since we are graphing, we could go decimal on this one. Square root of 2 is roughly 1.4-ish. So when you're getting ready to graph, just use your best guess here. So we're going to go 1.4 in every direction. And then connect your dots. There's your circle. Okay, same thing here, except they're just giving me a little bit different information. So there's our formulas. This time they're telling me that it passes through a point at negative 1, 1, and it is centered at the origin. Okay, so when it tells me a point, they're telling me the x and y values. So I know h and k because the origin is at 0, 0. So I know h, I know k, and from my ordered pair, I know x and I know y. So the only thing I'm looking for is r. So this is just a plug in everything you know and simplify. So plugging in everything we know, we get negative 1 minus 0 quantity squared plus 1 minus 0 quantity squared equals this r squared. Reducing down, negative 1 minus 0 is negative 1, 1 minus 0 is 1. Negative 1 squared, of course, is 1. 1 squared is 1, so we get r squared is equal to 2. Now, if I'm writing my equation first, I'm technically ready to write it because I now have r squared, and you can see right here, that's what our equation calls for. So you could pause and write the equation right now. We know h and k, and we found r. So I could just do, since we're at the origin, I can just do x squared plus y squared equals 2. But since we're getting ready to actually graph our circle, I'm going to go ahead and find the square root of 2 to be my radius. And I think we just found that up above in our previous problem, and we found that was about 1.4-ish. So there's our equation again, and when we clean it up, it ends up looking like what we already did. And to graph this, we're going to start at the origin. That's where the center of our circle is, and we're going to go 1.4-ish in every direction. And graph our circle. All right, what happens when it is not centered at the origin? Well, it's the exact same thing. We know h, we know k, we know x, we know y. So the first thing we need to do is to solve for our r value. So our formula called for x minus h, so we have a -2 minus a -1, quantity squared, plus y minus k, which is 1 minus 4, quantity squared, equals r squared. Go ahead and take a second here to clean this up. We're going to do -1 on the first parenthesis and -3 on the second one. That should give me 10 for r squared. And again, at this point in the game, we could write the equation because we have r squared. If we found r, we're going to go ahead and square root both sides. And we get r to be the square root of 10. And since I'm graphing, I'm just going to, what is that? About 3.2. So let's go ahead and try and graph this thing and get the equation. Right there's our equation. So again, h was -1, k was 4, and r squared was 10. So that's how we came up with our equation. And then we're going to plot -1, 4. That's the center of our circle. And we're going to go 3.2 in every direction. Now, another easy thing to do is to plot the point they gave me. So if I go -2, 1, that's a point that they've given me. So if I go 3.2 in every direction, 1, 2, 3.2, it's roughly in this area. 1, 2, 3.2 is about here. 1, 2, 3.2, again. My pen's not very good today. 1, 2, 3. So we're looking at about, circle right there.